Sir, participant have been joined, so you please continue session again.
Okay, thanks very much, Adil. Let me just start the session again. Let me share the screen. Can you please allow me to share the screen?
Please share your screen, sir.
I can't share you. It says host disabled participant screen sharing. Just allow me, I can do that. If you just quit your sharing, then I can.
Now, sir, please check.
No, I can't. Yes, I can. I can. Just wait 1 minute. Is it visible now?
Yes, sir, your screen is visible and shared with us, and voice is also very clear.
Okay. Thank you very much. Welcome back, all the participants. Let me just start. Probably the last time. Now, we talk about the air conditioning, how it's sustaining the world, and how actually it's assisting the materials industry and also the construction industry as well. And now, further, if you just apply the basic concepts, the thermodynamics is also making a impact.
West Tripoli, West Tripoli, West Tripoli.
The thermodynamics is also making an impact on waste heat recovery as well. So if you just go back for the slide, if I could show you the boiler here, okay. What happens here when you produce a steam, then it turns the turbine, and what happened to the rest of the energy? The rest of the energy being wasted. The rest of the energy which is being wasted possesses the temperature which is quite high as well, at around 800, 500. So why we are not utilizing that? We can utilize by recovering that heat. And now you are spending millions of dollars in importing the fuel like fuel on heavy furnace oil and kerosene oil. You can reduce your billings. How you can reduce? You can use a source. Sorry, you can use a source which is being run by waste heat. Now, if you just talk about the industry, like for example, the process industry where you have many heating process available, you can extract all those waste heat and also the heat from the air conditioning. You can use that waste heat and use a heat exchanger. A heat exchanger is a device which takes the heat from one fluid to the other fluid, and both the fluids are on different temperature. Taking that heat and transmitting that heat to the flowing water. Okay, and in that line you have water, and you can transfer that heat to the water, and in this way water would be heated to that superheated level, and then you can use that water in that turbine, and then your turbine would be running here. Likewise, you have also, you can see a condenser here, and condenser is also rejecting heat. So instead of that condenser is the output heat is also on high temperature, so you can also use that condenser for other industrial processes. Like in other process, you can use in some heating processes. You can use some in some you can say some steam processor which is being used in some machines. You can use that waste heat as well. So what the advantage of this waste heat is that disadvantage of waste heat, which is actually a system in thermodynamics known as cogeneration system, or you can say combined heating and power system, which is saving approximately 40% of their energy as compared to the local system. 40% is a huge thing. So the modern industry, when the install industry, they come up with these options here. They ask the energy companies to install such a system which is based on heat recovery, which would reduce their billings as well. Okay, now the waste heat recovery is not stop here. The topic is beyond that, and we apply this concept in internet air conditioning as well. Now, the normal air conditioning which you use in the home and mostly is based on vapor compression system. You always talk about the gas of the refrigerator. Gas of refrigerator is leaking. The gas is not enough, or air conditioning not working. Our compressors are badly destroyed. We talk about the gas. Actually, let me just clarify. It is not the gas here. It's actually the refrigerant. In technical terms, is known as refrigerant. Now, some of the problem associated with the refrigerant is that when it flows in the system, it has two phases. In some of the components, it has liquid phase, and some of the components is vapor phase. The other problem is that in the tube of the air conditioning, we have a small pores available, and there is always a leakage of the gases through that pores into the atmosphere. So in that way, the gases, or you can say refrigerant, leaks, and there is deficiency of refrigerant, and that destroy your air conditioning system as well here, and that also causes erosion as well. Third, and the most important problem with the refrigerant is it's not environmental friendly. There was a research that these air conditioning are producing a bad impact on the atmosphere, because these refrigerant are chlorofluorocarbons, which consists, that means chlorine, fluorine, and in some cases oxygen as well. That actually harming your ozone layer as well. Other countries where there's a huge application of air conditioning, like the Middle East countries, they are actually on the opposite threading to this ozone layer. So taking into that consideration, they design a system which is based on, you can say, absorption system, not like the vapor compression system. They design a vapor absorption system. Now, in that vapor absorption system, you don't have any compressor. Like in compressor, you have a piston moving and spots are wear and tear. You're compressing a fluid. They use, instead of that, a generator. In this diagram, you can see a generator is installed here instead of compressor. And the refrigerant is not like the refrigerant you have chlorofluorocarbons. They replace the refrigerant like the ammonia, water combination, or lithium bromide water combination. These two combinations are the most commonly used. However, there are other combinations are being developed as well. So the danger of ozone and atmosphere neglected here, that's fine. But the second advantage, which is actually related to thermodynamics and your consumption, is the generator uses the heat for the process. The generator uses heat for the process, not like that vapor compression where you get heat by compressing. It only uses the heat which is being flowed into the pipe. Now that heat could be produced by the fuel. Normally they produce by the fuel like the kerosene oil or heavy furnace oil. But this heat can also be produced, can also be extracted from some other devices. Like you have in industry, you have some, as I said earlier in the previous slide, you have lots of waste processes, lots of waste energy being released, like in processes, like in power generation as well. Why you're not using this for air conditioning? You have the generator, you can use it. So what in advanced air conditioning, what they do, they actually take that piping from that waste heat and uses that into generator for their processes. Now, in this way, they are actually saving their millions of amounts in the bill. And further, if I talk about this alternate air conditioning, this alternate air conditioning actually includes a part which is known as solar air conditioning. Now, how a sun which is hot is actually cooling your room. The hot sun is actually cooling your room. How is cooling your room? Because the generator which actually needs the heat is actually attached to a solar collector. The pipings are actually attached to a solar collector, and in that solar collector we have some kind of special fluids running through that. And that collector is actually taking that heat which is transferring to the generator, and in this way your whole of the air conditioning is working. Now here, in this air conditioning, you use that first law of thermodynamics, like Q is equal to U plus W, how much work is being done by the fluid. The knowledge of sensible heat and latent heat, the knowledge of enthalpy, and plus knowledge of psychrometrics we apply here in order to make that alternative air conditioning. This alternative air conditioning is still lagging in Pakistan, but in the Europe and USA, it's being applied in most of the areas. And my research was also, master research was also in that, which is on a desiccant air conditioning system. Now, let's talk about for the persons who study electrical and electronics engineering, and in the curriculum there is one subject like thermodynamics as well in the electronics engineering as well. Now, in electronics, you always think that it's always the current, the semiconductor, the transistor, the IC circuits and transistor all are using. But have you ever imagined these are all producing the heat, and how you are dissipating that heat? If your system starts to get heat up, one day it would get damaged. So you have to design a system which is cool in order to cool that system. So what happened in laptops, you have seen a small fan running beneath your laptop, and dissipating that heat here. That actually system or fan is actually known as heat sink. In thermodynamics, the heat sink means a place where you reject the heat. And that heat sink actually at the low temperature. The heat sink actually at low temperature. Like for example, if I have cup, which is a source, and this which is actually 100 degrees centigrade, and then you have here in the room you have 30 degrees centigrade. This is actually at the low temperature. So this is source, and this all the room is my heat sink. Like in laptops and electronic components, you have this small heat sink, and which is actually the fins, which is actually composed of fins here. Now, here the theory of conduction and convection come to take place. This one you can also see in your motorcycle engine as well when there is no water. You cannot use water for the cooling in this electronic devices, otherwise it's going to damage badly. How you cool that? You cool by the air. Now, it's actually a part of heat transfer, which is a subdivision of thermodynamics. In this way, in this device, we make a small balls of different materials. And there was research as well on the materials, like we use aluminum and copper, and there are many materials invented which we use in the cooling of the system. So in this way, the natural air blows, and the number of fans increases the area, and also a fan increases the heat transfer rate, and in this way it gets cooled. Now the fins comes in various designs like cross and like the parallel ones, and there are many configuration of these fins, so they can easily make or heat transfer easily. Actually, they have two phenomena, not only the convection, but the conduction also take place, like the component which is directly attached to the circuit is actually conducted heat through the molecules by the conduction, and with the help of air, blowing air, the heat is being carried away from the your circuits, and circuits get cool in this way. Okay. Now, another example which comes in laptop and especially in the mobile phones is the heat pipe. It's a small pipe which is mostly made of copper and some other materials as well, which is actually dissipating the heat. Now, your circuit is quite compact in the laptops and mobiles that it generates a considerable amount of heat. This heat is being rejected by the, you can say, the heat pump. It also uses the principle of convection and conduction, because in this heat pipe, you actually uses not only the material, but there is also working fluid which is actually being circulated in the pipe, and that that fluid also takes the heat away from the that fluid also take the heat away from the your electronic devices. Now look at that development. If you just think about that cooling towers, I think everyone has seen the cooling towers when they fill this car CNG, and at the petrol pumps they've got a huge bucket cooling towers installed on the top. And since the system is quite large and the water is flowing over there, it takes the heat from the system installed, and when they push the water up, and there comes the air, and that cools the system. If you use such a system in small in the laptops, how ridiculous that could be if you're using that small system. How they change the water into that efficient air cooling system with the help of this heat piping system, which is efficiently being used in these electronic devices here. Again, I would say here, this is also supporting electronic industry. This is also supporting your material industry. I was talking about the materials. Definitely, material is an integral part of the engineering, particularly mechanical engineering. And in the modern days, how they are taking this thermodynamics into consideration for their research in the material sciences as well. Further, if you just talk about the application of thermodynamics, which is some kind of on a massive level, is your pole-mounted transformers. In these pole-mounted transformers, since the application is quite old, but I would like to include here now. The previous transformer were quite large, very much heavy enough to lift. Now, if you just see for nowadays transformers, they're quite small as well. In this transformer, the same phenomenon is being used, like the convection of the air, and also a fluid is being circulated inside that cools the your transformer. The air which is outside is blowing, which is cooling your transformer, and the inside is being cooled by the fluid which is going in. Now, thermodynamics, apart from this, you can say the HPD systems, apart from this convection and convection phenomena, you can also see how thermodynamics is being used in order to cool your system. In industry, if you go for a manufacturing industry where you have lots of presses and you have lots of machineries, metal parts are moving, you can also see there are many heat exchanger present in the industry that being used to cool your system as well here, and that system can be integrated with a system to use that I mean dissipated heat as well. So further, if you go, another application which is being popular throughout the world is the thermoelectric refrigeration, which is on a small scale basis. Now, this thermoelectric refrigeration is entirely different from the refrigerator that you use at your home. At home, you normally use the Weber compression system. The same compressor system is being used where the piston is moving, wear and tear. And I talk about that refrigerant. The refrigerant is causing damage to the atmosphere. The refrigerant is leaking. Your system is damaging. It's quite different from that. But as far as the research is concerned, which I stated, is not taking much load as your home refrigerator can take, but it takes a little load here. It's at the moment it's on an experimental basis as well. This thermoelectric refrigeration is based on the Peltier effect. I think electrical boys knows it quite better as well. The Peltier effect has the device which has got two sides, and we give DC current to it, and that DC current makes one side of the plate hot, the other side is cold. I mean the cold enough of cold more than cold than your the object which is placed inside. So if you know the law, the heat flows from the hot to the cold side. So one side becomes the hot, the other side becomes the cold. So the heat which it takes it from the hot side to the cold side, and that cold, and both sides have the fans available. The same fan that you use in the laptop, you can see the heat sinks you use like a fans and a fan combination. The same you use in the thermoelectric refrigerator. It takes the heat from one side and then give off the heat on the other side as well. And in this way, your things get the cool here. Here also the second law of thermodynamics, the Clausius statement comes into contact. Now see how your big Weber compression system, which is quite bulky, which is quite consuming your thousands of rupees and the billings here. Now here you just using with DC system and AC system as well. Another advantage of thermoelectric refrigeration is that you can also integrate a small solar panel photovoltaic system with it, so that you can give DC current to it and your thermoelectric refrigeration would start working. In our university, we designed a thermoelectric refrigeration. I was student design for one bottle and one beverage can, and it's working quite efficiently. It's on an experimental basis, and still we are working on that to make it quite better as well. So just move out further. Now, this is the most important topic that I would like to discuss. That how this heat equation, how this basic concepts is actually transforming into bigger system, which is known as thermal energy storages. which is actually being used nowadays with the solar energy systems. Now, as the name implies, it says thermal energy storages. And these just two phenomena, some of them are based on sensible, some of them are latent, and some are based on both of them. Now, coming back to the word thermal energy storage, that means to store energy for a limited time, to store energy for limited time, to be used on that time when you don't have any source of energy. I repeat, you store energy for the time being, for some time, and use that energy for running your systems, for running your homes, for anything, when no energy would be available. The best example of this thermal energy storages are being used with this solar energy, as I said. What happened? For example, in this application that is written here is solar thermal collector. Now, this collector, for example, being used to heat your homes, the fluid is moving in, and then the sunlight comes, strike the solar collectors, and they heat up the fluid, and the fluid moves inside the homes, and that heats the water, and that water being used for domestic purposes. Just imagine, when you don't have any sun, and you don't have any resources, then how could you make your home a warm? Here comes the concept of thermal energy storages. Like in the daytime, when you have got better sunshine, you heat up your solar thermal connector, you heat up your homes, and at the same time, you use those particular devices in order to store your energy. Once there would be no sunlight, there would be bad weather conditions, you can use the same storage, you take the same heat from that storage in order to cool your homes, okay? Now, how this storage works actually? These storages were actually by some of the devices. I will not say the devices. Sorry for that. Let us say some of the materials. Again, we talk about the materials here. Some of the materials that are being used here for the thermal storages, like you have come to know the term of smart materials. Smart materials are the materials which actually changes their shape when temperature changes, and then they recover their shape when the temperature become normal. So in short, I would like to talk, like when you use a smart material for the thermal energy storage, there are many materials available like polymers and some chemicals, and it goes and goes and on. But they take heat from the sun, or you can say from the collector or any pipe. They change their shape for the sun time, and while their shape is changed, they store the energy. Now, soon they start to release the energy, their shape starts to regain. And it's not a matter of just a few seconds that they take the energy, they transform their shape, and then in a few seconds they dissipate the heat and turn to their normal position. No, not like that. Materials are being designed taking into consideration the temperature and the heat flow equations, the concept of convection and radiation. Materials can store the energy for long hours. For long hours, they can store the energy, and they will take a very small time, very differential time in order to change their shape back. And while the change is changing the back, they are still able to give you some of the energy, like for the 5 hours or the 6 hours when you don't have any sunlight available. Okay, so this actually I'm talk about the thermal energy storages, but I would like to add here one statement as well. These thermal energy storages are also being incorporated in the alternative air conditioning. Now, many research in the previous year have shown that you can use the same with this vapor absorption system, and you can add here the thermal energy storage, which is based on this latent heat. You can use that material, and you can use some of the chemicals in order to store this air conditioning. Now, as I said earlier, in this air conditioning, you actually need a generator, and that produces the heat. Now, if you just, for example, in industry, if you are using this air conditioning for 24 hours, now for the 8 or 9 hours, or for you can say 10 hours, you can use your normal fuel or normal, you can say waste heat recovery systems in order to use this generator. But at the same time, it's also storing some of the energy in the storage boxes. When you turn off your fuel, or there would be a night here, at that night you would be able to get that air conditioning 5 to 6 hours using that storage systems, using that materials for that air conditioning. And further research is being carried out on these air conditioning systems, which uses these you can say smart materials and the rest rate heat recovery system. Now look at the advantage. You using some thermal storages here as well, and using some heat recovery on the other end, and you would get a fuel-free air conditioning system. Now there would be no fuel being used, the only fuel used for the industrial processes that you use here, and also you can incorporate solar energy further if you want to increase your temperature to the desired level, and also the thermal energy storage systems. Now these system research are being also conducted in the buildings as well, and for the in the automotive sector here as well, we are using this thermal energy storage systems. And these are using the same equations of first law of thermodynamics and your sensible heat equation, latent heat equation, the concept of conduction and convection here. First law of thermodynamics equation is everywhere, whether design any system, whether we analyze systems. Once the heat goes in, once it starts to work, it would be everywhere. Now, further, if you just see the application that we always talk about the land and the earth and our buildings, the cars and the aircraft as well, the thermodynamics is also in the sky as well. Thermodynamics is also in the sky as well. How in the sky as well? Now, here if you have not noticed, the clouds that you see is actually the process of convection. It's actually the process of condensation. The actual rains that you just received recently in our city, the bad rainfalls, that actually all results of the condensation processes. Now let me just tell in the brief what happens when the sun radiation comes in. The water at the top of the layer of the ocean starts to get evaporated. Now here comes the concept of radiation. The more the radiation is, the more evaporation would be. The vapor starts to get up, and at the top the temperature is quite low in the atmosphere. It starts to get freezing. Now here the phase is changing. Look at the phase changing phases. We talk about the PV diagrams, the phase changing. Now look at the phase changing process, which is being occurred naturally. The water being converted, the fluid being converted into freezing, the solid state. Okay, and then these clouds move towards the land area, and that movement is caused by the winds. And let me just tell you, the winds is also being caused by the convection processes. The winds also caused by the convection processes. The winds move towards the clouds move towards the land, and because of the sunlight, there would be melting of that ice, and that condensation process occurs, and then precipitation occurs as well here. Now, how thermodynamics is also being used in the weather, and meteorologists use the modern tools and radars and modern softwares and the mathematical models, even the mathematical models they use in order to predict the weather conditions, and weather predictions are getting accurate day by day. And they use the same mathematical model equation like sophisticated differential equations and these radiation equations and this we can say convection equations in order to predict the weather here. Further, you can just search on the internet as well. So now thermodynamics is used from your daily life to the weather as well. It's quite a massive application in this mechanical engineering. Last but not the least, let me just talk about this computational fluid dynamics, which is a crucial part of mechanical engineering, CFD. The word actually says a fluid dynamics. That means the fluid, which I said the fluid, anything which can be flow, like we have got the liquids like water, honey as well, and from the gases like the air or hydrogen and helium gas and whatever it could be. Anything which can flow in a fluid. Now, software are being used for analysis of this flow, like the flow, for example, in a pipe, there is a flowing, how velocity is being, from which velocity is being flowed, and what with the velocity profile in that, and what with velocity at the end. At the same time, the software are being used in order to determine the temperature distribution any location. Now, this CFD system are also being used in the weather charts. If you can see, the color profiles here in this diagram and in this weather diagram as well. Look at how they made a color diagram in order to know which area of the land would get more precipitation, which area would get more heat up, which area would get more cold. Now these are the models that I was talking about. Now, in terms of thermodynamics, for example, I have given an example of a turbine blade. Now turbine, as I said, is being used for the power generation gas turbine. In this turbine, as I said, the temperature is quite high, and if you this turbine size is something very small, right? And this is small, the temperature changes abruptly, like from the bottom, the temperature is around 200, it goes to 400, 500, 700, 100. vertically and horizontally as well, the temperature profile changes, which is being showed by this color contour diagram. So why, for example, you are using this analysis of the turbine blade? It's actually you have to cool the system as well. If you just keep on heating those turbines blades, you get heat up, and there's a certain failure of the fatigue, especially in the aircraft engine as well. So you have to cool the system. In order to cool the systems, you know how much temperature distribution on these turbine blades as well, so that you can design a proper efficient system. And you use water jacket system, water cooling system in order to cool this system. So look at that, how thermodynamics is also helping the computer industry as well. We talk about the cars, we talk about the electrical as well, we talk about the weather, now we talk about the computer industry as well. Now these help the computer scientists to think about to develop such software which helps the mechanical engineer to develop this software. So yeah, how that dejected thermodynamics, which you normally neglect about the mechanical engineering, how it's diversified, it's in helping a lots of industry as well. So these are some of the applications of the thermodynamics I have discussed so far, and these are all the presentation. Thank you very much for listening to the presentation. Now, if you have got any question and answers, I would like to ask Mr. Adil to proceed the sessions for any question and answer, please.
Sir, can you hear me?
Yeah, I can hear you.
Sir, the session is about to end in 8 to 7 minutes. So I request with you to start the question answer session in the third part of today's CPD webinar. So I think we have to wind up. Some of the students have asked their questions. So I'm requesting with you to conduct the third session in which we ask or take the questions from participants.
Okay, yes, we have 6 minutes, so we can take the questions. The rest of the questions we can go in the third session after the ending one. So anyone else would like to ask?
The one question is from the participant is that what is the purpose of spark plug in our two-stroke and four-stroke engines? First, you answered this question, sir.
Yeah, thanks very much for the questions. The answer about the spark plug. The purpose of spark plug in the four-stroke and the two-stroke engine is used as a spark ignition engine. What happens? Let me just show you the diagram so that it will get much clearer. Okay, as I said, when the piston comes down, the intake valve starts to open and you get air-fuel ratio in. When the piston moves up, it starts to get compressed at the top, which we call the top jet center. It compresses, the pressure temperature rises, and if we don't make any spark, the fuel and air-fuel ratio do not have enough power to push the piston down. We just need a blast. We just need the what you call the enough temperature, which is actually designed by the engineers. In order in order to get temperature and pressure, so that it can push the piston down. It's for producing the work here. That's the answer of the question. Any other question, please? Yes, Mr. Adil, any questions? Mr. Adil, can you hear me?
Yes, sir. The next question of participant have asked that what is the difference between two-stroke and four-stroke engine?
Okay, now I've got the question. They asked what's the difference between a two-stroke and a four-stroke engine. I would like to answer shortly. In a four-stroke engine, you have four strokes like the intake, you have the compression, you have the power, you've got and the exhaust as well. The two-stroke works in only the intake stroke and the power stroke only. And in the four-stroke, you have one revolution of the crank in four strokes. While in two strokes, you have two revolution of the crank in two strokes as well. But two strokes have got some of the pollution issues with that, because there is a one compression stroke, you have fuel added to the exhaust that creates a problem here. but the only advantage is that you get more power in one revolution of the crank. That's the answer. Yes, Mr. Adil.
Okay, sir. No one can ask their question, so I think we have to end this session with a word of thanks because the session is uh, all with the kind of slides, so we have to end today's session. So I'm really glad you are joined today's session, and it's time to vote of thanks. Thank you very much, sir, for joining today's session and part of today's session that modern trend of thermodynamics and mechanical engineering. And we are very glad engineer Rehan Khurshid, yeah, assistant professor and OB coordinator, mechanical engineering department, West Hamdard University, Karachi, for sharing your valuable time, knowledge, and information with us. Hope you also conduct such kind of session in future as well. And now it's time to end today's session. Yes, sir. If you have say to anything, so please discuss any kind of things with your student, with participants, and future direction of thermodynamics and modern trends that will be helpful for research and development in for our participant and student as well. Thank you.
Uh, yeah, one thing I would like to add here is that, particularly for the students who are in mechanical engineering, I would like to say when they go into the field, they must read the information regarding the boilers, regarding the HVAC, and if they are going to the research, they must also know the connection between the materials and the thermal sciences here. They are going into that research here. And if they are studying this thermodynamics, then they should also concentrate on the heat transfer subject because that's also an essential part of your series. And also the heating, ventilation, air conditioning, refrigeration system, they must also concentrate on this because these are the most practical application subjects in our mechanical engineering. Then also the electrical engineering, electrical engineering also Yes, Mr. Adil, should we end the session?
Yes, sir. If you have to all about your site, so we have to end session with the all kind of protocols. Thank you very much again, Engineer Han Khurshid, for share your all the time. And now it's time to end today's session. The CPD webinar of participant and presenter certificates will be ready and share with you within 2 days. Hope you all gain the kind of knowledge with Sir Rehan Khurshid, Assistant Professor, Nobi Coordinator, Mechanical Engineering Department. Uh, Hopefully, he conducts such kind of valuable session in future with us as well. So now it's time to end today's session. Allah Hafiz.
Allah Hafiz.